So answer this for me then. Decide whether the statement is always, sometimes, or never true. A rhombus is a rectangle. Sometimes, always, or never. Now think about that for a second. Somebody want to take a stab at this one? What do you think? Yes, ma'am. Never? Rhombus is never a rectangle. Okay, well now if that were true, if it were never a rectangle, we could never find an example of a rhombus that's a rectangle. Can somebody give me an example of a rhombus that is a rectangle? Ah, a square. A square is a rhombus that happens to be a rectangle. Okay, but certainly we could find some rhombuses that aren't rectangles. So what does the answer have to be? Sometimes. Yeah, now, when you're looking at these on a test, honestly, if you have no clue, if you had to just guess completely, guess sometimes. Because sometimes is far more common. Sometimes means that I can find at least one example that works and at least one example that doesn't work. If I can find at least one of both, sometimes, guaranteed. Okay? A parallelogram is a rectangle. Yeah, now, what if it said a rectangle is a parallelogram? What would that be? A rectangle is a parallelogram? Always. Because there's no counterexample, right? But what about this one? A parallelogram is a rectangle. Sometimes, right? Because I can find some examples of parallelograms that are rectangles. Everything inside that set
that would have all equal.
That would be rectangles. But I can find some parallelograms that aren't. Like that guy right there. Right? He's a parallelogram, agreed? But he's no rectangle. And then I can find some up here that are neither rhombuses nor rectangles. Right? Does that make sense? Okay. What about this? A rhombus is a rectangle. Sometimes, because can I point to an example of a rhombus that is a rectangle? Right there. Can I point to an example of a rectangle that is not a rhombus? Right there, for example. Right?
But I thought you said that they have to have like all equal things for that.
Oh, hang on. I said that backwards. Never mind. I'm sorry. A rhombus is a rectangle. Square. There's an example of a rhombus that is, I said that backwards. I'm sorry. A square is an example of a rhombus that is a rectangle, right? Agreed? Because a square is a rhombus. It has 4 congruent sides, but it's also a rectangle. Can I find examples of rhombuses that aren't rectangles? Yeah, right there. Okay? So it'd be sometimes. Okay? All right. What about something like this? A parallelogram is a rectangle. Can I point to an example that's true? A parallelogram is a rectangle. Yeah. Right there? There's another one right there. Okay, a parallelogram is a rectangle. I can point to any of those. Can I point to an example of a parallelogram that is not a rectangle? Yes. Sure. There, right?
Oh, wait, a parallelogram.
That's not a rectangle. Everything inside this box is a parallelogram. Only those guys inside the brown ellipse are rectangles. Right? So that's a sometimes also, isn't it? Okay? Good. All right, so what else do we know about this? Now, because ABC is a rectangle, ABCD is a rectangle, because it has 4 right angles, right? That's the definition of a rectangle. But we know that all rectangles are parallelograms also, aren't they? Because rectangles are just special parallelograms. So all the stuff we've already talked about, all the properties of parallelograms also get attached to rectangles, because rectangles are parallelograms, right? Does that make sense? So we know, for example, opposite sides are congruent, and parallel for that matter, right? Opposite angles are congruent. Consecutive angles are supplementary. The diagonals bisect each other. All that stuff that goes with parallelograms also must go with rectangles. And rhombuses for that matter, because rhombuses are also parallelograms, right? Okay. What else? What else? Let's skip forward a little bit. there's some other things we know, some special things that apply only to rhombuses or only to rectangles. For example, we know that if I've got a parallelogram where the diagonals not only bisect each other, but are also perpendicular to each other, that guarantees me that that's a rhombus. Because only in rhombuses are the diagonals perpendicular to each other. Okay? If I've got a parallelogram where the diagonals, in addition to bisecting each other, they also cut the opposite angles in half. They bisect opposite angles. So for example, let's make sure we understand what that means. In this parallelogram, diagonal AC then is bisecting angle A, cutting it into two congruent little angles, and is bisecting angle C, cutting it into two little congruent angles. Right? And the same thing for diagonal BD. It's cutting angle B and angle D into two congruent small angles. Okay? If that's happening, that's also a property of a rhombus. We know it's a rhombus. Okay? If the diagonals are congruent to each other, then I know that it's, in addition to being a parallelogram, I know that it's a rectangle. Okay? So I get some other special stuff. Diagonals of a rectangle are congruent. Diagonals of a rhombus are perpendicular, and they bisect opposite angles. Okay? So let's get some practice using this information, and then this is kind of all we'll do today. So what about in this one right here? Can we, in the diagram at the right, we know that PQRS is a rhombus. We're given that it's a rhombus. What's the value of y? So whenever we're solving for a variable, it's always the same drill for us. We want to come up with an equation that we can use to solve for y. So we got to know a geometry relationship here of a rhombus that allows us to solve for y. Well, what's the relationship? Let's see. All we're given is that the length of side PS is 2y plus 3. The length of side RS is 5y minus 6. So what's the? Do we know a relationship there? Yes, sir.
2y plus 3 equals 5y minus 6.
Yeah, all the sides of a rhombus are congruent, right? So we could just set those equal to each other. And then that's an easy thing to solve, right? If I add 6 to both sides and subtract 2y from both sides, I get 3y equals 9. So y is just 3. Okay? Make sense? Okay. Oops. Start there. Okay, and then here's a summary of what we just talked about, using the diagonals of special parallelograms. The following theorems are about diagonals of rhombuses and rectangles. So we know that if rhombus, then diagonals perpendicular. Okay. Now there's something kind of cool about this one, because I want to point this out. Now pay close attention to this, because this is it may not seem like a big deal now, but it will be. If a statement uses if and only if, that means it goes both ways. It's like an arrow going both directions. So what this is saying is, if I've got the condition that we have a rhombus, and we're connecting that to the statement, diagonals are perpendicular, the if and only if part is like that. They go together. So I can say if rhombus, then diagonals are perpendicular, or I can say if diagonals are perpendicular, then rhombus. Take your pick. Either one of them works. Okay? Did you ever see that? Okay, so you're getting both the theorem and the converse in one. It's a package deal. When it says if and only if, it means I can go in either direction with that statement. I can start there and end there, or I can start there and end there. Okay? That's a lot of people miss that in geometry. That's something that, when you see those if and only if statements, people just fail to always recognize that.
Well, what do you mean if and only?
Well, notice that it says if and only if in the theorem. If and only if means a bidirectional arrow. It's called a biconditional statement, technically. We don't need to know that. Right, so we can say both. We get two theorems for the price of one. we could say if rhombus, then diagonal is perpendicular, or if diagonal is perpendicular, then rhombus. They're both included. Yes, sir.
So could we use answers in Moodle like theorem 6.11?
No, you can't. You gotta. And the reason I don't want to do that is because I don't want it to be tied to just a textbook. I want it to be something that that you could use outside of the textbook. So you'd have to say if rhombus, then diagonal is perpendicular. Okay. And then the other thing we know is that rhombus and hang on. Okay, that's that one. Okay, we're doing one per page. Here's the other one. If rhombus, or a rhombus, if and only if opposite sides or opposite angles are bisected by diagonals. Okay? Right? So if the diagonals are cutting the opposite angles in two, then it's also a rhombus. If the diagonals are congruent, then it's a rectangle. But it's an if and only if statement, right? So rectangle and perpendicular, that's a property, in other words. Not perpendicular, I'm sorry. Congruent diagonals always goes with a rectangle. Okay? Goes both ways. I could say if rectangle, then congruent diagonals, or if congruent diagonals, then rectangle.